Welcome, guys. I will be doing the lecture today, and Biagio is going to be my amazing help of the day. If you have any questions, please do send them to the chat so we don't have multiple interruptions. So let's start. So today I will be using the following tools. I have a Jupyter notebook ready for use to demonstrate everything we will learn today. I have the terminal open, which is this little black square right here. So the terminal is a program that allows the user to use the computer without having to deal with it directly. It is, in a sense, a protective shell that prevents the user and computer from coming into contact with one another. And through this terminal, we are able to launch our Jupyter notebook. To do so, it's very simple. You actually call on the Jupyter notebook. There we go. Enter. And that will give us a local host that it open on this screen. Give me 1 second. Here we go. So this is what Jupyter looks like. We will also be using the platform that's called Learn.lewagon, the one that you have been onboarded on, which is this one. Learn.lewagon, this platform is provided to you for your use and to practice. You'll be able to go back to the videos, the slides, whenever you want, and of course be able to practice with the given challenges. It is organized in a way for you to follow instructions, so you can finish the challenges, take a quiz to see what you have learned with us tonight, and finally a feedback form if you are kind enough to give us a little bit of a feedback. So of course, once we are done with the slides, you can ask as many questions as you possibly have. I will have, right, so now I am gonna keep my slides open and I'm going to keep my Jupyter open. So I'm going to be doing a back and forth between coding and demonstrating the slides. All right, so let's begin. All right, let's see if I is this big enough for everyone to see? Or should I make it full screen? Are we okay?
I think it's fine.
Fine, because it's easier to go back and forth. Okay, so let's begin. Welcome again to Data Analytics, the Data Analytics workshop. Today, we are going to see two main things. The agenda covers two topics. First of all, Python 101. So we'll see some basics of how to use and understand the programming language Python. And the second part will be the actual interesting part of the workshop, your first exploratory data analysis. I will be using three open source libraries that are called Pandas, Matplotlib, and Seaborn for data visualization. So the very first thing we have to know about is what we call the Jupyter notebook. So this is what it actually looks like. Once we opened it, I already installed my data and I have my notebook that I can open right here. Great. So little disclaimer, you are going to practice afterwards. You will need to install certain packages to be able to use them, such as Python, Pandas, Seaborn, etc. And I believe that's all in the platform, in the Learn platform. So let's have a look at our notebook. It's a text editor, as you can see. It's made out of cells, and you can have as many cells as you possibly want. There are three types of cells that are very important. The first one, which are code cells, Markdown cells, and raw cells. Every cell starts off being a code cell, but its type can be changed by using a dropdown right here. As you can see here, we have Markdown, heading, and which is technically a Markdown, and the raw and the convert. Okay. All right. So the Markdown is basically can be used to title sections. Let's say here we want to say, let's start. Okay. To pass something into a cell, you actually need to press Shift, Enter, and that becomes a Markdown cell. And the code cell can be used for pure code. For example, let's do 2 plus 3. If you Shift Enter this, it will give you the output 5. Okay, so let's go back to our slides. So let's go back to Python 101. Now that we know how to use the tool, let's see what it is the first thing to learn about Python. Every programming language uses data types. there are some built-in data types, such as these three main ones. We have numeric, which is an integer or float. We have text, which is going to be a string. And finally, we have a Boolean. Boolean, which is basically a true or false response. The objective of this Python 101 is just to give you an idea of what are the basics that we need, and to move further into data science. Of course, there are many, many more things that we have to learn in a programming language, but these things are the basics that we need for today, okay? So first type, as we saw, is numeric. So let's go back to our Jupyter Notebook. The best way to handle a Jupyter Notebook is to constantly be clean and organized. So now you don't just type, right? Because when you are working as a developer, you want to share your information to your colleagues, and you want to make sure that they understand the pattern of what you're doing. So let's make this a Markdown, and we're gonna do data text. All right, so the first one to see is integers. An integer is any number, right? So we can make it a 4, we can make it a 5, we can make it as many as we want. To actually, so the next part is the text one, which is a string. And we're going to visualize all this. So the first thing to do before we go to the text one, if you want to see what kind of data types you have, we have, there's a really cool function, built-in function that says type, and you pass on the argument 4. You shift enter, and it tells you that this is an integer. The next part would be a float, to visualize what a float is. A float is any number. The difference between the two is any number that actually has a decimal, okay? So let's do type of 3.876, and that shows that as a float. Oh, so now let's see text. We want to write, say, I don't know. Hi, my name is Kenza. A string, a text will be considered a text when it's between 2 quotation marks, okay? To actually double check that, you can always use the type function that will tell you exactly what kind of type you're dealing with. And the last type we will check is the Boolean one. A Boolean is really just a true with a capitalized T, or false with a capitalized F. To make sure that this is a Boolean, you can type and double check, and it will tell you exactly what kind of information you have. So make this a comment. Here we go. All right, the next thing before we move on will be, I'm gonna make this a Markdown, will be to get acquainted with this ideology of what we call Boolean algebra. So Boolean algebra is when you are able to do operations such as true and true, which will give you a response. If you say true and false, the response will be false. You can also do true or false, false or false. And you know, it's infinite. You have so many more. So a piece of advice is to always make sure what is the data type that you're working with. There are some data types that might be, let's say, hybrid. An example, if you take, say, a zip code within the UK, they have letters and numbers together. We are combining now characters, and that's like a text type and some numbers. I have only introduced these 3, numeric, text, and Boolean, but there are so many more that exist, such as, say, lists and dictionaries. But for now, let's focus on these, okay? Let's go back to our slides. Cool. Sorry. we go. So next are variables. What are variables? So when we work with code, we want to be able to store information into, say, placeholders, okay? Or an object that can contain some data. In this case, we use variables. Jupyter, let's go back to our Jupyter, and we're gonna be able to show you what are variables. All right. So the first example would be, say we want variable, let's declare the variable city. City, I live in Casablanca, so that would be my city. To make it, you have to make it a string, so Casablanca, because it's a text. Go. If I am to run this cell as a variable, it will contain the value that I just gave it to. So this is one of the patterns of Python. It's an object-oriented programming language. It means that we have objects, they have data, and they have a behavior. By data, we mean the information stored that can be of any type as you want. And behavior means that this data can be transformed by the use of methods and functions. That's the paradigm of object-oriented programming. And one of the most important things to understand is that this equal sign right here is not like the algebra equal sign. It is just assigning Casablanca to the city, which is the placeholder, okay? So when we run that, now Casablanca lives within the variable city. When we run programs, the compiler, which is the notebook, will read it from top to bottom. So we're gonna start from top to bottom, and then it goes from right to left. So right here, this will be read from top to bottom, and then it will read Casablanca. It will understand that this is a string. It will see that this is assigned to something, and it will assign it to city, okay? Cool. Let's see if we type now city, what would it give us? Casablanca. So now just make sure to remember this kind of pattern. So, you know, we can go through this workshop and everything seems clear. Next would be functions. Let's look into what functions are. So programming languages have built-in functions. Let's see an example of what this is. The document, by the way, all the slides are interactive. So every time you see that there is a underlined blue text, that means that it's linked to something. Once you open it, this is what we call documentation of Python. This is the latest one of Python, the latest version. So when you're going to be able to install it, it will, on your computer, it will have built-in pieces of code that you can call on your objects and perform what they are meant for. Let's see an example. Over here, you can see all the types of built-in functions. And if you want to understand what are their purpose and what do they do, you have all the right information right there, okay? So let's go back to our slides and we're going to show you some kind of built-in functions. Okay. So we're going to make this a Markdown again. And put this up. Cool. All right. Say we want to know the length of city. How many characters are existing in city? Because right now we are visualizing Casablanca, we can count. But say we have the longest sentence and we don't know how long this is. There's a really cool function called len. You type len and you open your parentheses and then you pass as an argument whatever you want. It can be any type of object, okay? For this one, we're gonna give it our variable. Once you Shift enter, it will tell you how many characters exist within this variable, okay? We have two types of syntax that we're gonna look through. The first one, let's say, we're gonna write it here. Syntax one. The syntax one is, basically you type out the function, so the function name, and then within its parentheses, you pass on the object that you want the behavior to change, okay? So to know the details on how to use the built-in functions, please refer to the documentation for more information, okay? The second one will come next. We're gonna look into it now. So there is a different way of calling function. We will look into it now. This is what we call stored objects, basically, and we are going to call the function on the object and not the other way around, okay? So let's go back here. syntax 2. Object dot function. Let's say I'm going to create a variable name. So my name is Kenza. And I want to capitalize this name. The way to go about it, you pass on the variable, so the object, and you give it a point, and you pass on the built-in function, capitalize. Sorry. All right. Once you do that, my name has been changed. But if you go back to name, it will go back to the first variable and how it was written at first. So if you want to actually make this set in stone and in place, you set the same variable back to name that capitalized. So now this exists within this variable. Tonight we will be, today we will be looking mostly at the second syntax, the one that we just done, because it's just much easier to use. Therefore, you always need to refer to the documentation. And let's go back to our slides to continue our little bit of Python 101. I think this is pretty much it about Python 101. Let's go back and check out what we've learned so far. So we know now what is Jupyter Notebook. We know how to use it. We've learned of the different data types. We have numeric, integers, floats. We have text, which is a string. We have Booleans, true or false. We learned about Boolean algebra that will come handy later. We have created a variable. We've learned about that and what functions and how they can change behavior to objects. So what's next? Data sourcing. So the first stage of data analytics or science is that we need data, right? Data sourcing can be considered quite an art. It's not like we are getting it from out of the blue. We have to actually go and fetch it. So there are many ways to collect data. The most basic way to get the data and the one that has a legacy is CSV. It's a format that you might have come across because you can export a CSV through Excel or Google Spreadsheet. CSV stands for comma separated values, and almost every software can export the information that it contains. Another way would be data that is stored in a database. When we are developing, we store things in databases, and the information lives there within tables that are connected to each other. It can also be found on websites. For example, you want, say, the exchange rate of euro to pound. That is the data that lives on a website that you can go and fetch. The next way is through APIs. And the API stands for Application Programming Interface. It's an endpoint. If you have a database, you can push your information through the API format, which will be a JSON file, readable as an endpoint. But what I mean readable is not us humans will be able to read it, but machines will. So APIs are being used in the daily by developers to facilitate development and really make life easy. And finally, by receiving data through files by email. Okay, so data comes in many ways. It's not the way we structure it, but also how we receive it. What we mean by structured data is that our machines will be able to read it in an orderly manner, like JSON and CSV. It's ordered for us, so it's really simple to interpret. And then we have unstructured data, such as PDF, text. It's more challenging to fetch the data because it's really everywhere. And the third type that exists is binary or proprietary. What we mean is that the data isn't available for everyone, and you might have to ask for authorization and pay for it. Data is online, right? That's how we actually get it. It might be just on the internet, accessible to everyone, or behind, say, a VPN where they create a firewall that you have to pass. Maybe you have a password or not to obtain it. There are many ways to actually read these data. The first one is with SQL, stands for Structured Query Language. It's a way to read databases and have access to it. You actually push a query with simple English wording almost. It's say, let me give you an example. Say, select a name from this table, restaurant, okay? When you start having a big data, we start needing a new tool, such as using a server in the cloud where we store information, but can still have access to it by using SQL. You have APIs, and each API has its documentation to know how to access the right information. And finally, if none of the above are available, we can use web scraping. Web scraping, this one is a little more complex because it has to replicate or mimic how much interaction, how humans are interacting with websites. We use let me try to show you here. For example, if you press Command Option J, that should do it. Yeah, here we go. See that little box that opened on the right? If I press on that little arrow, I can select any part of this website and have access to all the information, all the HTML that lives within here, as you can see. So here's it's a div, we have the class name, we have all that, and that's how you do web scraping. So you have to go and fetch the right environment where it lives and put it into your code, okay? So let's get back to here. Okay, so where can we find find some data sets? We can either use Google Dataset Search or Kaggle. So let's open these. If I click here, it will not take me anywhere. Great. Open new tab. Here we go. So this is how it looks like. It literally looks like a Google search engine. Over here, we can do a simple search of any topic. Here, it says try coronavirus, it tries education. So we can, like, if you press on here, it shows you what kind of data you have access to. You have the WHO, from WHO, you have from Data Europa, you have access to a lot of databases. And another one would be Kaggle. So Kaggle is a startup that was bought by Google as well. And today, the cool thing about Kaggle is that you constantly have competitions for data scientists. So a lot of people go there to just like participate and try to set their models and what kind of scores they got. It's really interesting. It's really cool. You have competition on the left, and then you have your data sets that you can go and fetch. They have such a variety of data sets that you can play with all the time. So today we're gonna focus on New York City Airbnb. This is open source as well. Everyone can use it. This is what it looks like when you open one of the data sets. It gives you all the details that you're going to be receiving. As you can see here, we are getting a CSV. So that's great. It's a structured data, easy to use. You have all your columns, what kind of information you get within the columns. You have your host ID, the name, you have your neighborhood group, longitude, etc. You have, when you compact it, it's just show you all the information like within like maybe 10 or 20, and you can download it right here, as simple as that. Okay, I already downloaded it. It already lives within my folder, so I don't need to actually go back and do this. Cool. Go to my slides. Okay, next will be Pandas. So Pandas is an open source library that allows us to treat information. It was built for Python to handle data. At this point, you might ask yourselves, why not use Excel? That's basically the tool of excellence for analyzing data in the last years. I've used Excel my entire life. However, when handling large data sets where there are millions of rows and thousands of columns, it might just crash due to the way it gets read. So that's where Pandas comes into place. It efficiently allows you to combine tables and files and do whatever seems necessary to the data. When you pull data from APIs in the JSON format, you'll be able to straight away like work with Python and Pandas without the need to treat it. So if you actually are receiving APIs JSON format, you can't interpret it directly to your Excel. It gets really complicated. So Pandas IO tools. The IO here stands for input and output tools. The dataset that we downloaded is a CSV, as you've seen earlier. And in order to read it, we will need to import the library Pandas. And then it's very simple. I'm going to demonstrate this now. Okay. So we are here. Also, there are so many shortcuts of how to use your Jupyter Notebook. You can Google a cheat sheet and I'll show you. To change the cell from code to Markdown, it's as simple as escape and M, okay? So we are going to do Pandas now. Great. The first part, I already have everything installed, so I don't need to actually go into my terminal and install it. So import Pandas. We're going to say as PD, so it's easier to like type out. As we just say, use this shortcut to code out. That's it. And now you shift enter, and it just installed into my Jupyter notebook. Okay. The next part will be to see where does this notebook lives? Where is it nested? What's cool about Jupyter is that you have access to command lines just like when on a terminal. So if you do exclamation mark and then PWD, that will show you the path of where that exists. And this one exists on my desktop data analytics. If you want to visualize what's inside, you do, all right, you do exclamation mark LS, and that will list out everything that's within. So that's the name of my file that we are on. So that's fine. And then we have the data one. The data one, that's where my data lives in. So the way to go about this now, let me just put this higher. It's very, very simple. We're going to go back to my main thing. We're going to open data, and then I'm going to see what the name of my data set is. I'm going to copy that. I'm going to go back here. I'm going to show you, actually give you this here. So you can visualize at the same time. So we know that this is our file path, and we know that data lives inside of this folder. So we don't necessarily need to do like we don't have to write the whole path. We can just start from where we are. So we're going to do a pd.read underscore CSV. And to do that, I'm going to copy the name of my data. Since I know it lives inside of data, I need to call data and then give it that. As simple as that. If you do it, shift enter, my data is loaded into my Jupyter. So let's call this listings underscore data frame equal this. So again, we have just created a variable as a placeholder for this data. So if I do and shift enter, it's gone. But if you want to visualize it, you just call on UTF. Okay. All right. Let's go back to the slides. So I mentioned the word data frame earlier. When we load the information through Pandas, it gets loaded into a data frame. It is a 2x2 array. So if you go back, actually, if I want to see how big my data frame is, you can see here that we have around 50,000 rows and 16 columns. And that's how you kind of like have an idea of what you're dealing with. So another important library we need to focus on is Seaboard. Just like Pandas, it is an open source library based on Matplotlib, which is another like built-in library. These will help us plot and visualize the data. So part of the job of a data analyst and data scientist is not just passing straight to the fancy embellished code. You will need to get a sense of what kind of data you are working with. In order to do this, we have like multiple tools to go through. So the first one will be to check out the shape of our listing. So if you do listings.df and you pass on the function shape, it will tell you, it will give you this information right there. Then other things we can do with this data frame, maybe if you want to visualize the columns, only the columns, you can do, so listings.df.columns, and that will give you a list of all the names of your columns. Another thing that you can do will be checking what is the data type of all of these columns. And that is one of the most important things that you have to check, because you need to know what kind of data type you are working with to know how to use the functions and the methods. So here we know that the ID column is an integer. The name is an object, the host ID integer, we have floats, we have objects, we have a bunch of different types, okay? And the last one is dot head. Dot head is a function that will allow you to see the first 5 elements in entries in your data frame. So you can see here we have 1, 2, 3, 4, 5, which is cool. What is cool about head is that you can pass on an argument inside of it. So you say, I want to see 10, I will write 10, and it will give me the first 10, okay? By now, we got a sense of the data that we have and what we're working with. So the next stage will be needing, so I already downloaded the thing. I have loaded my CSV. We kind of took a look at the shapes and the columns, and now we're going to be doing some cleaning of the data. Cool. So let's escape this and make it a markdown. We're going to do some cleaning now. All right. The most important part of being a data analyst and being a data scientist is to clean your data. You never receive the perfect data. It doesn't exist. So most of your time will be spent on cleaning data, okay? We can check, for example, how many nulls are found in each column by calling this method on our data frame. So let's say listings.df, and we can call the method is null, okay? When you do that, everything is going to be transformed into a Boolean between false or true. So if it is false, it means that it's not null. And if it is true, it means it is null, okay? It summarizes basically how many nans are found within each column. And nan stands for not a number, so it's a null value. The information the information isn't there. This happens often in data sets. So it's important to really get rid of your nans or replace them in a way that makes sense, right? So before doing any statistical analysis, you need to go through the stages of cleaning and then working with it. Now we can visualize what is null is doing, but we don't want the false and the true. We want the summary of everything that exists within these columns. So you can do a sum on all of that. And once you do that, it gives you a very nice and clean idea of what exists in our data frame. So here we know that name has 16 nulls. We know that host name has 21 nulls. We also know that last review is around 10,052 nulls, and the same thing for reviews per month. Okay. It is when it is a 0, it means that it has 0 nuns, and it's very good for us. We don't want to touch those. Cool. So what we want to do, what do we want to do first? Let's check. We want to be able to drop the columns that are not necessary for us. Okay. So let's say we're going to do that. The first part is that we created a variable called columns to drop, and we gave it a list. This is what a list looks like. It's between brackets. A dictionary will be between curly brackets like this. Cool. So this is a list. We passed on ID because we don't really care much about it. For today, I'm going to drop also host name because it's not going to give me any information. And the last review, that's not really, we want all of the reviews, not just the last review. So you create that variable, and then there's a cool function called drop that you can pass on directly to your object, so your data frame, and give it all the column names that you want to drop right here. Once you put the list, so I'm grabbing this variable into my function as an argument. And then the next parameter is axis. Axis is going to give you what kind of, what axis to handle, if it's going to be the columns or the rows, okay? And the in place equals to true is going to actually make it change. Because if we don't have that, it will, just like before when we did the dot capitalize, it changed for a second and then it was gone. So we want to actually make it a copy of it. Okay, so let's run this and see what happens. So now, if we see listings underscore df dot columns, listings. We don't have the ID anymore. We don't have the host name anymore, and we don't have the last review. It is all gone. So now let's check the status of our data. We can do the isNull function again with the sum, and it is all gone from here. Okay, so let's now think about these 10,052 nuns that we still have. We don't want to drop the column because it's a very important column for us. What we want to do is fill the nuns with, say, zeros. So it's just like almost like a placeholder for us to function, to use the data and do our statistical analysis over it. So to do so, there's a really cool function as well that you can use. It's called list. You're going to do listings df. So you're calling it on your object, and it's called fill NA. Fill NA, you open your brackets, and you're going to pass on a dictionary. So that's how you will pass on dictionary. You're going to try to target the column name. So that's reviews per month. We're going to make it as our key. So that's going to be that. And then you tell it that you want to change it with zeros. Okay. Same thing here. We need to say in place equals to true. So I understand that this is a change that needs to happen through it all. All right. So let's go and check again our status. And it is all gone. We have no more nuns. Okay. All right. So everything seems great for now. Name, we're going to need, so we're not going to need it much. So we shouldn't really care about the 16 nuns. But yeah, we can move on to the next part. Columns and rows. So there are two ways to read data frames and to filter columns. One is called series, and the other one is called data frame. Let's try to see what the difference is when you code it out. So listings df. We're gonna give it a little bit of a comment so we don't get lost. Series. Cool. So listing dfs, let's say I want to grab the column name, okay? If you just enter it this way, it will pass on a series. So it's like a column, right? It's two columns. It gives you like the ID of the information that you receive from the column, okay? Yes, hello? Hello, someone has their microphone on? Okay, sorry about that. Cool. So that's what a series looks like. It's basically an object that comes back with, it's similar to a data frame, but it's just like a column that happens to have the IDs, okay? So if you want something different, which is a data frame, we're gonna do it in this manner. We're gonna write here data frame. And I'm gonna pass this. So the first part is that we want double brackets. And then you can pass as many names of columns as you want. So let's say we want the name, we want the, I don't know, say neighborhood group. We're gonna just copy this. And we want price. Okay, so if you enter shift this, it will kind of make it in a cleaner and beautiful way. It's the difference between these two. It's really just how we pass the square brackets. We're passing 3 columns in the second one, and it's going to be given back to you as a data frame. Okay, so the last part would be to see it this way by rows. So you are able to also grab the amount of rows that you want, and that you pass it by the number of ID. So let's say I want from 0, because it always starts from 0 all the way to 10. If you click on that, it will show you from 0 to 10 entries. And of course, you can start from anywhere. Let's say 1,000, and you want from 1,000 to 1,050. It will give you exactly that one, okay? All right. And you can also pick what columns you want. So if, say, I want name only, it will give me just the name of exactly those indexes, okay? All right, let's get rid of this because it's too long. Say 10, say 5, and we're gonna do 0 here. Let's go back to the slides. So Boolean indexing. Boolean indexing, at the beginning of our workshop, we looked through what Boolean algebra was, and now we are going to see the importance of what Boolean algebra does. So we want to see, for example, how many rows are lower than 100 in the price column, and which are the listings are basically less than 100. The output that we get is a column of the prices that has true or false booleans that respond to our algebra, okay? It will allow us to compare whatever we want. So let's try it out so you can visualize what I mean by this. So now listings df is your data frame. You are grabbing the column price, and you can know now because of what we've seen that this is a series, and you're telling it you want only the prices that is less than 100. So let's go through that. It will give you back all the list of the column of prices, and all of them that are between that are less than 100 are true, and those that are beyond are false. Okay. What else can we do? We can select and filter out. Say I'm interested in only analyzing the Airbnb listings that are on a specific price range. Okay. To do so, you pass this statement inside of your data frame, and what it does is that it grabs on all these true and falses, and it gives you back the original values. Okay. So let's now store it into our data frame. Let me do listings.df. You open your brackets and you copy what we've just wrote inside. Say, if you look into this, now we have a new data frame that is half of what we've seen earlier, which is around 20,000, and before it was like 48,000, so almost half, and with 13 columns because we've deleted a few ones. Let's say we want to call this affordable. Yeah. Yeah, we're happy with it. Cool. Let's say maybe 500 instead of 100, so we can have more to play with. So now, if you want to look into affordable, you can just pass the variable, and it will give you back all of this information. All right. Good. So now we've seen what Pandas can do for us. So let's make maybe a small recap before we move on, so everyone can be on the same page. All right, so Pandas. So the first part of Pandas, you import the library. You check where you are, where is the notebook living at, and you input your data. To do so, you use the function read CSV. Of course, there are so many different functions that you can use. You have read JSON, read HTML, they can read anything you want. Then we have checked a little bit of what kind of what we're dealing with, what is our data set. We checked the shape, the columns, the type, and then we looked into the entries that we've received. Then we started doing our cleaning. We checked if there are nulls inside of your data frame, and yes, they were. So the first part, we did a drop. We removed some columns that weren't necessary for us. And the second part was doing a fill NA, which is replacing the nuns with anything you want. This 0 here can be a name. It can be any object, okay? Finally, we saw the different types we have series and we have data frame. We learned how to grab them and how to be able to select the entries with their index. and how we are able to use Boolean algebra to really be more precise and concise into how to use our data frame. Okay, cool. So all right, so finally we can do some data analysis. So data analysis starts by demanding a strategic point of view. Let's say you have business, you'll need to think about the right questions to ask the data, how it can help you answer and how you can make your business develop better and grab the right decisions for it. So this is where it starts becoming actually interesting. What could we do? In the data science world, this is called EDA, exploratory data analysis. So we're gonna be answering some questions now. The first question we have is, what are the 10 most reviewed listings? Okay, so let's do a copy of that so we can target it right here. Let's say we're gonna call this question time. And we're gonna give it what are the 10 most reviewed listings? Okay. All right. So I'm gonna try to solve this. We're using only data. Okay. There are multiple functions on Python that we can use to start our analysis. We might start by grouping by entry and tell it to give me back the 10 most reviews, right? But here, the best function to get what we need for this problem is called n largest. So what you do is you call on your data frame, you pass on the function n largest, and n largest allows you to give it exactly how many numbers you want to receive. So the function is gonna demand an argument. So I want 10, and it tells you from what column you want it. So for this one, because we're doing reviews, it has to be the number of reviews. This will ultimately, all right. This will ultimately just give you the first 10, as you can see, and the largest numbers that you get from number of reviews. You have 629, which is the highest, and it goes towards the 10 highest, which is 480. Okay, so what else can we do? There's another question that we can target, which is, what are the NY neighborhood groups with listings, for example? So now we want to know, we have to do something such as give me like the unique neighborhoods within the listing data frame that we have. And how can we do it? Okay, we call on our listing df. So, listings df. Okay, and we're going to slice it in our neighborhood group. This column, in the neighborhood group column, and we're gonna use the method unique. Unique is gonna give us back all the unique elements within this column. Okay, so we know if you want to grab a specific column, you can pass on brackets, and we're gonna do neighborhood group. All right, so where is it? It's right here. We can just copy. Also, it's very important to have exactly how the column name is written, or else it won't detect it. So say if I got rid of that, it will give me an error, okay? So by doing this, you get a series of all the names. You have Brooklyn, you have Manhattan, and all that. So what we want here, we wanted to combine all the Manhattans, all the Brooklyns, all the Queens. So it gives me all the listings, all the neighborhoods groups that we have. To do so, there's a function called .unique that you can pass. Once you do that, it gives you an array of all the neighborhoods that they have within the data frame. So here we know that we have Brooklyn, Manhattan, Queens, Staten Island, and Bronx. Let's say we can do it again with the room type, because it's also, we can see here, it's also private room and it's repeated, an entire home apartment. So let's see what lives within. That's room, if I remember, type like this. Cool. So we have three unique values that lives within the column room type. We have the private room, we have the entire home apartment, and we have the shared room. All right. Let's get to the next question. We have a follow-up. How many listings per neighborhood group? What the question is asking us is to count the number of listings per neighborhood. So how many listings do we have per neighborhood? Okay. So there are many ways to do so, but the best way and the easiest way, again, that's the beauty of Pandas and all these, like Python there are so many functions that are facilitating the coding process for you. So you can straight away go to use them. So here we're going to do listings again. We're going to call on the data frame. What we want to do is grab the neighborhood group again. So we're just going to copy this extra. And this time we want to do this function, value underscore counts. So value counts is going to do the same. The first part is going to be like the unique one. It's going to put together all the entries that exist within the column, but it's also going to count how many listings it has within the column. Okay. So let's see. So we have 21,000 entries for Manhattan, which wouldn't be shocking. And then very closely Brooklyn. And then we have Queens, Bronx, and Staten Island with like the least number of listings that exist over there. The analysis that comes from this number is very simple. It's very straightforward. And that's the beauty of this whole data analytics side, is that everything that you do really comes into perspective, right? So the data is provided for you to play around to get the right number. And finally, as a data analyst or scientist, it's your job to make sense of this and to give back to your colleagues or employers like the right information to get to the next stage of your business. All right, let's get to the next question. The next question would be, what are the top 10 neighborhoods with Airbnb listings? So let's go back. Sorry, that was bothering me. All right, 1, 2, 3, and I'm going to put this here. Okay, so what we've done earlier is we grouped the neighborhood groups ahead of time, but now we want the top 10 neighborhoods with Airbnb listing. We will be using value count as we've done earlier, but we're going to be using it on a different column. Okay, so let's just grab this. And we're going to grab just the neighborhood, because this is grouping all the neighborhoods into big categories. And now if you get rid of that one, and if you go to just using the neighborhood, it will give you Harlem, it will give you Lower East Side. It's very more like intricate. So if you do that, we're going to see how many we have 221 information given to us. Okay. So this is giving us all of the neighborhoods, and we want to select only the top 10, right? The amazing thing about value counts is it's already ordered in a descending manner, so you don't have to go and do it on your own. So all you have to do now is really pass on the function that we've done earlier, that .head, and say I want argument 10. And that's not going to give you exactly the top 10 neighborhoods that you within the Airbnb listings. So here we see that Williamsburg is number 1, Bedford is second. Interesting, because those are all Brooklyn ones. All right. So now we're going to start plotting. Let's get to the next phase. We're going to use Matplotlib first, which is a built-in plotting tool. And later on, we will be using Seaborn. Okay. So let's try to grab this and do it straight here. Okay, so basically the only thing we have to do here is use the method onto what we've grabbed earlier. We are using the method plot. And it gives us with the right arguments, you get everything you want. So here we are using parameter kind, and we're saying I want to see my graph as a bar graph. For this plot, it's very easy and clean to visualize. And once we run this, we get the exact plot for our top 10 neighborhoods listings. So let's check this out. It's nice, it's beautiful, and it's very clean and easy to read, right? So let's use another tool. Now we're going to see Seaborn. All right. Interesting. Give me 1 second. I'm going to have to actually import Seaborn for this one. Again, same thing as Pandas. You just say import Seaborn as SNS. You pass that, and now it's within my Jupyter Notebook. Okay. Seaborn, it is also a plotting tool based on Matplotlib, but it's slightly improved. For example, for this problem, we wouldn't need to manually like group the neighborhood and do the counting and all that. We can use a simple plotting plot function that they already have on Seaborn. It's called count plot. All right. So if you go here, so here we imported Seaborn. So you're calling it on Seaborn. This is the function count plot. What count plot is doing, it's asking you for the data. Where am I doing this count plot from? You pass the data inside of it, and then your x-axis, you say I want only the neighborhood group. Okay. So when you do that, it will give you the 5 top. I mean, it will do the counting for you and share it in a visual. Let's try to do room type as well, just to visualize it, is it? Okay, room type. Here, same thing. You can see that the largest number of the largest type room is an entire home or apartment. That's what the listings, the most famous listings. Then the smallest one is the shared room. So not a lot of people like to share rooms. And finally, the private rooms. Okay. If you want to order this, there's a really cool way to do so. You can create a variable order. The variable will take on your listings df, right? And you are grabbing the neighborhood group. So now we know that we are only grabbing one column. Did someone call me? No? Okay. And then we're doing a value counts. And finally, we're using this really cool function. It's called .index. So in here, it's going to give us just the index of our value counts. Then we're going to do a count plot. Same thing as before. The data is the listings. The x-axis will be the neighborhood group. And finally, we're saying, hey, I want you to order it by these indexes. Okay. So if you do that, you get it in a very clean manner. Of course, you can do that with any of the different columns. All right. Next question. So what's the influenced neighborhood group on room type? Let's open Jupyter. For this question, we will be needing 2 columns. We will need to get the room type as well. Just like this, listings underscore df, square brackets, room type, and we can just grab the unique values of room type, okay? Listings. Okay, so we know the 3 types that we have. By calling the method unique, we can see like the different types that we can use. And we want to use a count plot again. So we can do an SNS count plot, open your parentheses, pass on your data, which is your data frame, which is listings underscore df. Hopefully I did not make a mistake. And then you pass on your x-axis. You still want to use the neighborhood group. So neighborhood underscore group, I believe. Oh, it's with a U. It's British. Okay, and then there's this other function that other parameter that they have. It's called hue. So the room type is now a hue that will be passed on for every neighborhood. Once again, if it's like reading data in a visual way, it's sometimes more useful than only numericals. That's why the plotting tools are very important. And the hue, you will see now its performance and how amazing this little tool is. Awesome. So now we are doing the count plot. We are counting per neighborhood groups, but within each neighborhood, we're telling it, hey, give me a hue of how many private rooms, how many entire rooms, and how many shared rooms are comparatively. All right. Now let's pass to distributions. The question we are answering here is, what is the distribution of flat prices? Do we want to know how people are listing their flights? And maybe through Seaborn, we will use the method .displot, and we'll pass the right argument for it, okay? So if we take on this question and make it right here. What is the distribution of flat prices? Put this up. So another cool function, plotting function, it's called dist plot. Yeah, dist plot. This plot will take on flats, so listings, yeah. And let's say we want to see prices. Is it price? Yep, I think it's price. Yeah. Cool. So we can see here that we have, wait, let me make this a little bit bigger because it's a little too small. PLT.figure. I'll explain this later. And then fix size. Sorry, I need to import Matplotlib as PLT. So now this should do it. Module is not callable. Why not? PLT.figure and then fix size 15.8. I'm having a little bit of an issue with this, but we'll figure it out later. All right, so we can see here that most of the prices are living between 0 to, let's say, 1,000. And that's where the density is it's the highest. And then, of course, we have outliers that live between the 2,000s all the way to 10,000. So when we have, yes?
I think we forgot to import Matplotlib. That's the issue.
Which I did right here, Matplotlib as PLT.
Oh, okay. No problem.
So that's very weird that I wasn't. That should work. Maybe the spacing. Let's see. Module being not callable. We'll look into it later. Maybe I have to update it, whatnot. We shall see. Okay, so we see that we have some outliers, and earlier we created a affordable DF that really just takes on the prices that are lower than 500, right? So we can filter out again and get a distribution of the data frame that we have created earlier. So if anyone remembers, we have affordable DF right here, and it is all the numbers that are lower than 500. And what we want to do is create set account plot SNS that count, I mean not count plot, the dist plot. And pass on our data frame. And let's say we want to see the price again. So now we have a better visual of what is happening in the background. Nothing is too condensed. We got rid of the outliers, and now we can see, like, we can have an idea that this is a normal distribution, and what can we do with this kind of information. Okay. So this is very useful for statistical analysis. We can also get, for example, the average of the prices that we have between the listings DF. Let's say we can also call on columns by just passing on the name like this. Let's see, and we can do the same thing for our affordable DF. So we can, you see, there isn't like much of a big difference, but it is still important to get rid of your outliers before you move on to the next stages. All right. We did this plot. We got familiar with the 500, the affordable data frame. Now we are going to answer this question. What is the distribution of the flat prices based on the neighborhood group? We'll make this a markdown. I'll pass on this question here. And I'm going to put this all the way up. So this time we'll be using different type of plotting. It's called a violin plotting. It's a very cool demonstrative visualization. So let me grab on this and pass this into our cell. So basically, again, all the different methods that we use with Seaborn and Matplotlib are here to give you graphs. This one is giving you, it's also like almost like a histogram with different types of parameters. It's basically the same thing as the other graph, but turned at 90 degrees. We can still see that Manhattan is seems to be the most expensive because it's like the largest, right? So it's extended. Yeah, I really wonder if this time we could like work out if figure again. Size is equal to 15. Okay. Yeah, my module, I need to update it for sure. Okay, next. Oh, sorry, I did not do the right interpretation. There we go. So the first one will work now. Awesome. And here is gonna work as well. Awesome. So figure is it's a method that you can use from Matplotlib, and it will allow you to create different figures. You can create a grid. You can create so many different ways to visualize your charts, okay? So next will be, can we plot the listings on the map? Let's see if we can do that. They already give you a nice scatter plot. So in here, we are plotting, right? That's the method we're using. What kind? The kind parameter here, we're giving it the argument scatter. So we want really every dot to be scattered everywhere. We are saying X is going to be our column longitude and Y is going to be our column latitude. And our C, which is going to be the pricing of each one of them, is going to be the column price. You can know what kind, like within here, yellow is one of the highest and 0 is the darkest. Then CMAP is Inferno, which is just like controlling what kind of coloring you have. What else? We have alpha, which is the opacity. So let's say we have 3. It'll be much clearer, but I like it with a good 8. And finally, your fixed size, which is 12. 08. You can change that as much as you want. This is what we call a scatter plot. In order to create a map, we're back to using Matplotlib that now I have imported correctly. Now we can visualize, like, say, the NYC map. They offer you a really cool example here. You can add it by importing requests. Request is also a different library and image as well. So if you pass, it is not happy. Let's see if this map still contains. Yeah, that should do it. Okay. It's not happy. Okay. Image can show image dot open. Say image open. It's image. Okay, well, now it's working. Cool. So now we just literally incorporated another image to portray the scatter plots on top of our New York map. You can now have more of a clear idea of where things are situated within the listings Airbnb one. All right. Okay, so next we are going to, we're getting closer to the end of our workshop. So going further, here are some topics for another time, and for you to, like, maybe if you are curious enough, if you're interested enough, you can go and look through them. The first one is what we've talked earlier about, which is SQL. You can never be too good for SQL. I just till today still practice and still try to make my knowledge and query as good as I can. This is an example of like how you push a query. You use different tools to get there. You have, say, Postgres, you have SQLite, you have a bunch of softwares that you can use to get to the right information. Here, we don't have, this is just an example, so we don't have birthdays and we don't have age. We're working with a different data frame, but it's a very cool and easy tool to know of. The next one is APIs, just like what we've seen, import requests. So what we've just done now, when you get an API, so you get a key and you get a token that's yours, you interact it with your code, and you have to import requests to be able to get that information from their documentation. To know where to find that, you always need to go into your documentation. Say, I'm gonna show you a really cool one. It's called Mapbox. So Mapbox, I believe it's Mapbox. Let's go to my account. Yeah, here we go. So this is my account. This is what it looks like. This is the access token. So every time you make a request to your API, it knows that this is yours and it's coming from you, and that's how they will be charging you. Next to it, you have all the documentation that they have. You can search it. I don't know. It's a geocoding. Geocoding is what we use to, for example, when you are on Airbnb and you type an address, it will never be like the longitude and latitude. It will be street, zero, and the name of this and zip code, and it's very complex for the computer to actually read it. So what happens is that we use a map box and we use the geocoding to get that from the address, the longitude and latitude. Okay, so maybe I'll show you an example of that is, let's say, for example, this one. This is a query for the address 515 15th Street, Northwest Washington, DC 20004. I mean, we can just look into this link, and this is going to give us back a JSON format. All right. So here's the JSON format. You have the address name here, and you can see directly that you have the coordinates right there. And that's how you are able to visualize your address within a map. Okay, so that's the point of APIs, is really to facilitate like code. For example, if I have to come and I want to start a business and I want to put a map in it, I cannot start mapping out, like coding a map from scratch. It's going to take me ages. It's inefficient. It's time consuming. And the best way to go about it is go to Google Maps or do Mapbox. And you have so many different APIs that are available for you. Some are free for the first 50,000 requests. Some are a little more expensive. So it really depends on like what kind of information you need to grab from there. Okay, so let's go back to our... We go back to our slides. And finally, web scraping. Web scraping is really the last thing you go for, because say I am scraping Airbnb, I don't know, and and they see that there are many requests from the same IP address. They can block you. They can stop you right there. They can change their code, HTML, and then all of the hard work you've been doing can be changed in 1 second, and that's like heartbreaking. So this is really like the last resource you get to. And it's kind of the same thing. You also import requests and you use this really cool open source. It's called Beautiful Soup. Beautiful Soup is going to be, is the parser. It's what, well, understands HTML and it goes to the page that you give it. So you give it a URL. And once it is inside of the URL, it will go and find exactly what class you targeted, what title you target. It really depends of like what HTML you are using. Okay. Finally, machine learning, which is going to come tomorrow. Machine learning is the fun part for me personally. I enjoy this a lot. They come in hand, right? Today, what we've learned is that there's a whole process, pre-processing that happens before you create your model even. So tomorrow we are creating models, but today we clean the data, we visualized the data, understood the data, did some statistical analysis. We visualized it as well. And at the end, like, our data is perfectly ready to be used into a model and to be trained. So it doesn't have like any problems when you're training it. So your turn. This is the end of my lecture. I hope you enjoyed it. I hope it was interesting, and I am ready to answer any questions you have. Before we get there, I want to show you a little bit of the platform. So inside of your platform, you have access to certain instructions, like what kind of things you have to install. By the way, you can directly just do, say you want to install Python. It will lead you towards the right information, but just write pip so it knows what you are declaring. All right. Sorry, I think I have to do it the other way around. Install pip Python. Yeah, so it gets me. See if we can get it from here. All right. Anyways, you will, here we go. Anyways, this is going to take me a little bit of time, but just go to the right information to start like installing what you need to install. So next you have your video. You will also have another person that did a similar workshop a long time ago that you can go through. You have your slides, and finally you have your challenge. The challenge is going to ask you to download this as CSV. It's going to ask you certain questions. You can just click here to start a notebook. And when you're done, you can mark a scene. You can submit your work here. Then you can test your knowledge with a small little quiz. And finally, if you need more sources about Pandas, about all this, everything is, we're giving you like cool links for you to inform yourself more. And finally, thank you. And it would be very much appreciated to have a little bit of feedback. I will now stop sharing my screen. And I am ready to answer some questions.
There is a lot of thank you on the chat message.
Oh, that's nice.
Thank you so
guys.
much, Kenza, for this very interesting lecture. Again, it is only a foretaste of what you can learn at Le Wagon Bootcamp. If you are interested about the data science bootcamp or the web development bootcamp at Le Wagon, don't hesitate to reach out to me, to go to the website of Le Wagon. And don't hesitate as well to learn a lot with the Learn platform. I've shared the details on the chat. So don't hesitate to train yourself, to come back to the slide, to come back to the lecture, and I will share again on the chat how to get your Le Wagon certificate and to be onboarding on the Learn platform. And if you have any question for Kenza, you feel free.
Yeah, please do. You can just unmute yourself and come up with any question you have. Charlotte, I think someone is asking if they need to do the challenge to get this certificate.
Yes, yes, I'm writing now to the link to share your details and to receive your certificate on Sunday.
Cool. I hope
thank you, Kenza.
Tomorrow for the machine learning.
Yeah, this was quite interesting. Thank you so much for sharing your knowledge. We will take questions, but please, anyone who wants to ask a question, you will find the reaction buttons in the bottom. You can raise your hand and go ahead and ask your question. Maybe we can start by asking Kenza about the role of a data scientist. Where can data scientists work? What is the importance of this new job role, if I may say?
Yeah, definitely. I mean, you can, by now, we are in need of data scientists everywhere, right? So you can create better applications. You can make things automated. You can just, it leads you to efficiency in any job. So we can even start as the basics. An e-commerce platform can need a data scientist to create automated recommendations, to create, just automate a lot of things that have been done in a weird manner. So yeah, I think it's needed everywhere. It's the new. We hear a lot of it. It's a new job, but it's really not. Like it's been around for a little while, but it just has been more trendy and more like heard of. Yeah, I think that's pretty much what I would say. I think Hassan has a question. Go for it, Hassan.
Hello. First of all, thank you for the wonderful session. It was really interesting, and I really enjoyed it.
Thank you.
My question is, in 5 years, what's your plans, and how, let's say, for example, will you use talents of many people around the world to improve your system and systems all around the world?
Personally, right? For me, I am working with Le Wagon, but I'm also working on my startup. I am using as much knowledge that I can have every day. And that's why I love Le Wagon, because it's constantly pushing me towards looking for information, towards like digging deep into what models do, what is the mathematical and the mathematical background as well. I do not have any specific like timeline for 5 years. I have milestones, say. And for me, my milestones is really working on my company, but at the same time, constantly getting more and more knowledge, because you have to understand is that machine learning, deep learning, AI, it doesn't stop. It's not something that you learn and that's it. It's something that constantly is evolving. It's something that changes, you know, by the minutes sometimes. What you've learned, like, you know, a week ago, it could be completely falsified, and something new can come up. So it's really important to keep up. I hope that answered your question.
Yes, thank you very much.
Thank you so much. We have another question from Sruthi.
Yeah, good afternoon, ma'am. Thank you for the session. Ma'am, I'm a Stack developer. I've been working on PHP, HTML, JavaScript, and ASP.NET, and I've recently found data science as an interesting field. I wanted to know, like, apart from Python, what else do I need to, like, improve on so that I'm ready for this field?
Of course. Are you considering to go into a boot camp or something, or are you just trying to learn on your own? That would be my first question.
Currently, I'm learning on my own from all the YouTube videos and tutorials.
Okay, so really, then you have a very good base. So what we've learned today is kind of the structure of what you need to do. You're going to need to start by learning Python, really be efficient with it. You need the background of SQL. It's always good to have understanding of what SQL does. Then you have to go into APIs and web scraping. So also, because it's really about how to fetch the data, how to do and pre-process the data, and how to manage the data, right? So it's really step by step. You start by Python, you understand how to fetch the data, you understand how to clean it, and then you get to the next levels, which are modeling, optimizing. Yeah, but I would say just continue in a very like organized manner, and you should be fine. But it's always good to come to us at Le Wagon. We can teach you everything.
Thank you, ma'am. One more question, ma'am.
Yes, please.
Yeah, in UAE, do you see that like if I switch my career into learning more on data science, I have a good future?
So I personally was a web developer first. I did that in 2015, I think, or no, 17, sorry. I think it was 2017. I enjoyed it. It was fun, but data science is really something that goes deeper in a deeper level. Personally, I think it's interesting. It's incredible. One of the projects that I worked on was automating hand movements. So we were able to get a data set of EEG signals from brainwaves. And through that, we got 6 types of movements, right? So we had the hands going up, going down, like 6 different types. And what it does is that we were able to create a model that will predict these kind of movements. And that's basically for amputees who will then work with a prosthetic, and it can be a smart prosthetic. So it's up to you, right? Are you interested enough to go deeper into like the data side, or are you more into the web developing? It's really just a question of you.
Thank you very much.
My pleasure, of course.
Thank you, Kenza. We have lots of questions in the chat. I don't know if Charlotte, would you want to read a few of them out loud, and then maybe Kenza can answer them?
The most questions are about how to see a job career about data science, or how to join a career in data science. So maybe, Kenza, you can tell us what are the best skills, or what are the skills to have in order to do a career in data science.
Well, the first one will be Python. And then you really need to, I would say personally, it helped me a lot that I went to an institution like Le Wagon that was famous and known, and it makes it much like serious that I'm a data scientist, right? But if you are doing it on your own, you have to do projects. Send to your GitHub, have your GitHub do as much practice to showcase what you have learned and what kind of talent you have.